Hi, in this video I will introduce software we created for music expressive meaning research I conducted under the supervision of my advisor Dr. Chris White. This software analyzes facial expressions during each bit of a musical excerpt, generating data to evaluate the emotional attributes of individual musical slices. Before diving into the program's details, I will first share the end-user experience. Through a measured listening section, the program detects bit numbers, musical modes, all voices of chords, bass, tenor, alto, soprano 1 and 2, and facial expression values for each bit. Once the program is terminated, it generates an Excel file that pops up on the screen for observing and analyzing data. This diagram outlines the signal flow of the system that processes facial expression recognition data in real time, integrates it with music generation, and facilitates further analysis and data outputs. The process combines JavaScript for facial expression recognition detection, MaxMSP for musical and statistical analysis, and Python for advanced data processing. The system begins with the JavaScript layer, which is responsible for detecting facial expressions from a real-time video feed using an application programming interface, which is called Phase API. The Phase API.js script, as the server, receives this phase expression recognition data via WebSocket and forwards it to MaxMSP using the Max application programming interface. This setup enables seamless integration of facial expression data into MaxMSP for further processing. The MaxMSP layer is the core of the system, where the received phase emotion recognition data is processed and combined with musical and statistical operations. This layer includes several functional blocks. Using the Node.script object, the phase expression recognition data is displayed in MaxMSP, providing real-time feedback to the user. This visualization is critical for monitoring and debugging during the process. Chord progression and discrete unit generator creates chord progressions based on associated musical modes and bits. First, the metro object sends signals to the system in each 600 milliseconds that corresponds to 144 BPM, and this provides the discrete units. That means in each 600 milliseconds, system evaluates data and outputs the result and begins again till the program is terminated. Blue buttons trigger modes inferred from chord progressions as Ionian, Dorian, Phrygian, Lydian, Mixolydian, Aeolian, and Locrian respectively. Red objects consist of the logic and data of the generated chord progressions. The player object sends these signals to Ableton Live to trigger virtual studio instrument technologies. Fill and Draw unpacks the phase expression recognition data for each detected expression and counts its occurrences in each bit of the current tempo. Phase emotion recognition statistics processes the counted phase emotion recognition data, converting it into percentages for easier interpretation. It also smoothens the data to reduce fluctuations, presenting a single value that can be used to represent the dominant emotion in each cycle. Data value display displays processed data, which are user number, bit number, musical mode, bass, tenor, alto, soprano 1 and 2, and phase expression averages. Once the phase expression recognition data and musical parameters are processed, they are transferred to a data transfer layer for further use. This layer includes two main components. The data is organized into an array structure containing various elements. The processed data is prepared for transfer to other platforms using the user datagram protocol. This allows the system to communicate with external applications or systems, ensuring flexibility and interoperability. The Python layer processes and organizes data received via UDP from the maxMSP layer. It listens for incoming UDP packets on a specified port, extracts relevant musical and phase expression recognition data, then organizes it into a pandice data frame. Once the musical excerpt is completed, the program saves this data into an Excel and displays it on the screen. This provides a clear output that is ready for further analysis. This system exemplifies the integration of real-time facial expression recognition, music generation, and data analysis. JavaScript manages phase expression recognition detection and WebSocket communication. maxMSP dynamically processes musical and emotional data, while Python performs advanced data structuring and output. Together, these layers offer a robust tool for analyzing emotional attributes in music, bridging raw facial expressions with musical interpretation and statistical evaluation for research or artistic purposes.